this session is about low-level design. We will only be talking about low-level design. How many of us here are working professionals? That is, you have graduated out of college and you are working with some organization. Okay, so why I have asked this question is because if you are a working professional, then weightage of low-level design becomes much more. See, if you are in college, if you are writing some code in your lab, or if you are writing some code which is a part of some lead code contest or code forces contest, then the design part doesn't matter a lot. All that matters is that the code functions correctly on different test cases, right? Yes or no? But if you work for an industry, then there it's not just enough whether your code compiles correctly or gives the right output for the right input. It's not just enough. The functional correctness is not enough. You have to think beyond functional correctness. So what is beyond functional correctness? There are so many things which are beyond functional correctness. Maintainable, clean. Okay, what does it mean? Let's pick them one by one. Let's pick the first word. You said maintainable. So when you say maintainable, what do you mean? Like what kind of maintenance activity you have to do for a code? Let me give you a very simple example. Let's say there is a code base. Let's say you have joined a company and there is a legacy code base. It is a huge code base, okay? And you are asked to implement a new feature, okay? Now, while implementing that new feature, you had to introduce some lines of code in different files. And let's say you did that. So when you did that, you ended up seeing that lot of the other features which were functioning well, they started to fail. I mean, when you introduced something new, the other things which were working well, they kind of started to fail. So have you ever been in this scenario that you introduced a feature and because of that, the existing test cases started to fail, or the existing feature itself as a whole started to fail? Have you ever seen that? So there is a term for that. There is a well-known term for that. People call it as blast radius. That if a blast happens, then what is the radial distance that that blast is going to cover? So let's say you make a code change, right? Let's say you make a code change and something you missed in that. Maybe some null pointer exception handling, or maybe you messed up with some existing flow, or you messed up with the data model, or the change that you made was backward incompatible for the legacy features. So what is going to happen is that a lot of things are going to get affected, right? So such a code where blast radius is very high, or to keep it simple, such a code where you have to worry a lot about existing features is something which is called as a fragile code. Low-level design kind of teaches us how not to write fragile code and how to write a code in which making changes is very easy. See, when do you make a code change? Let's say I'm your manager and I give you a new task that, hey, go ahead and add this feature. Add a feature which allows a user to search something based on an ID. What is the first activity that you will do? So there is a huge code base and I have assigned you this activity. So the first thing that you will do is you will go ahead and read the existing code base. Yes or no? Yeah. So when you say check the previously written code, you mean the first thing is to read the code, read the huge code base. And when you are reading the huge code base, then you figure out that, okay, this is the function in which I have to make the code change. This is the API in which I have to make the code change. Or this is the class which needs to be changed. So you read a lot and then eventually you figure out that here a single line of code change is to be done. Making that single line of code change may just take 5 minutes or 10 minutes, right? But the process of reading would definitely have taken maybe 1 day or 2 days. Sometimes, depending upon how large the code base is, it even takes weeks. So what do you think? Which activity consumes most amount of the time? Is it code reading or is it code change? What do you think? Definitely it is code reading. So if you type this question on Google or if you ask ChatGPT that what is the ratio of time which an average developer spends in reading the code and in writing the new code, you will be surprised. In fact, do it today. Do it and see what is the read to write ratio that you are getting. Now, for reading to be fluent, for reading to happen effortlessly, the code has to be clean. The code should feel like it's not a mess, because the more friendly it is for you to read and navigate. So yeah, you're going through the lines of code, you're going through different classes, functions, and if you're able to connect the dots very clearly, then it's very easy. Then the task that would have taken you 1 week, you might be able to finish it within 1 day or 2 day, because the reading effort is very, very low. See, low level design does not have much to do with the functionality. By functionality, I mean the purpose of low level design right from the beginning is not to reduce the latency of your API, or to increase the throughput of your system, or to introduce a layer of cache, or to introduce the graceful degradation on your system. No, these things are part of high level design, okay? Or optimization at the level of data structures and all, if you go till that low level details. Low level design is for humans, that if I'm a developer and I'm going through a new code base, it should be easy for me to navigate through it, so that I can implement the code change earlier than what I could have otherwise implemented. So it enhances overall productivity. Do you get the point? How many of you now understand that what is low level design and what is the true purpose of it? Those of you who said that we are absolute beginners, we don't even know what LLD is, do you now kind of understand what actually it is and why it is important? So let's do one thing. We will talk about a problem and we will see the elements of low level design into that. So I'm not sure like what is the programming language that you guys are familiar with. Somebody might be good at Java, somebody might be good at C++, Python. I have to pick one language, I'll pick Java. But don't worry, because conceptually, whatever I'll explain, that is language agnostic, that is just design focused. So I believe that will make a lot of sense. So today we'll just do a simple example, right? Where I'll show you that what kind of power some low-level design patterns can offer to your systems. So let us say, let's take a simple problem. Let's say you want to design a pizza store, maybe for Domino's or KFC or whatever. And now what you want is you want to support different types of pizzas. So you want to support different types of pizzas, and so that means that you may start with a very simple pizza. Let's say you just have a cheese pizza today. But as the company grows, you might start supporting cheese mushroom pizza and olive cheese mushroom pizza and all sorts of things, right? So you have to design a system for that. And when I say design a system for that, for now, we are going to focus on very limited functionalities. We are not going to focus on everything like payment system, login, logout. No, we are just going to focus on the pizza inventory in general. Or I would say the different types of pizza, like how we support different types of pizza. Okay, let's take things very simply. Like when you talk about pizza, there are different attributes that it can have, right? I can say that, hey, let's go ahead and create a class, name it pizza. So we have a class called as pizza, and I can say the simplest thing that it will have would be name. Every pizza will have a name, and every pizza will have a price too, right? So these are the things that it will have. And then I can write getters for the name and price. So I will generate the get functions. Those of you who are not very familiar with Java or anything, nothing to worry. See, you can see that this is an entity called as pizza. Class is an entity basically, right? And every pizza is composed of certain attributes. There are several attributes, but for now I am keeping things simple. So I'm just having name and price attribute. And this is the constructor in which these attributes are being set. And these are the get functions through which I can get the name and the price, right? Now, if I wish, I can just go ahead and say that, hey, let me an instance of pizza, which I will call as cheese mushroom pizza. And the price that I'll keep for this is 100.5. So now you can see that I have very comfortably created a pizza. And what is that pizza? It's a cheese mushroom pizza. So now I can go ahead and I can retrieve the details of this pizza through the get method. I can say p.getName, and then I can say p.getPrice, and this way I am able to get all the necessary details. So if I run this piece of code, you will see it kind of works perfectly well for you, and it prints the desired result. Cheese mushroom pizza and 100.5. Tell me one thing, what is something which is not pleasing about this piece of code? What can go wrong in future as we expand our company to support different types of pizza? Just think about it. See, there are several problems, but we have to start from somewhere. So let me start talking about some very simple things. Let's say tomorrow you want to introduce a new kind of pizza. Okay, and that pizza, let's say, is cheese mushroom olive pizza. Okay, this is what you have. Now let's say this cheese mushroom olive pizza has a particular field inside it, and that particular field is something which is specific to olive. It is specific to olive, right? So if it is specific to olive, then that variable which is specific to olive should only reside in this sort of pizza. You get my point? For example, let me let me give you a real world example. Let's say you have cheese mushroom olive pizza, and let's say olive is a substance which has a lot of allergens inside it. Okay, so what I want is that any pizza which is topped with olive, I want it to have something called as allergy score. Now, allergy score is an integer. Let's say it's a simple integer. So you might be tempted to say that, hey, let's do one thing. Let's go ahead and create an integer private final int and call it allergy score. And let's say it is used somewhere in some function. Let's say some function, there is a function which looks at the allergy score and does something on top of it and decides whether this pizza is to be recommended to this person or not. Let's say I'm the user of the app and I have listed that I am allergic to olive, then it should not be suggested to me, right? Now tell me one thing, is it a good idea to have this variable inside this pizza class? Given that it is specific to olive, is it the right thing to do? The answer is no. Why this is not the right thing to do is because, let us say you want to initialize a cheese mushroom pizza in which there is no olive. In that case, what is the allergy score that you are going to put? So existence of variables which make sense only to specific types, the existence should be there in those particular classes only. It should not be there in the generic class. So going by definition, if somebody says that let's say now there is another kind of topping that I want to support, and I call that topping as let's say onion topping, and let's say there is something which is specific to onion, you might want to have that again inside this class. So this class is going to become a class which will need frequent changes inside it. Need frequent changes. What happens to a class which is frequently changed? That class grows and grows and grows, so it bloats. It starts to contain so many variables, so many functions, and over a matter of time, it is very hard to maintain such a class, right? So there is one design principle which says there's a design principle called as open close principle. Have you heard of it? How many of you have heard about open close principle? What does it say? It says that if you have a class, then it should be open for extension and closed for modification, right? Here, whatever you are doing to this class is modification. Modification literally means adding a new line of code inside the existing class or deleting some code from the existing class. So if you do modification, that means you are introducing the chances for that code to fail. Some unit test cases might fail, or some features themselves might fail, right? When we say extension, I said no open for extension. What is the meaning of extension? Extension means that, okay, today, whatever classes I have, they can support these varieties of pizza. And now if I have to introduce a new variety of pizza, then those classes are not going to create a problem. Rather, they are going to support. Okay, so we will see that in some time. So see, one problem that we have seen is that if there are variables that are specific to different ingredients, we will have to accommodate for those inside this one single class. So what a lot of people do is they say that, hey, let's do one very simple thing. Okay, let's just make this class as an abstract class. Now see, when you make something as an abstract class, what it basically means is that that particular class can have certain functions which can be implemented by its children. Okay. And if you're not very sure about abstract class, I would remove it for a while. I would say let it just be a simple class. And let's do one simple thing. Let's create a lot of child classes of it. Okay. So I would say, hey, go ahead and create a class called as olive pizza. Now this class olive pizza, it's a child, so it extends the existing pizza. Because it's a child, so you all of you know a little bit about inheritance, right? If it inherits that, that means all the resources which are mentioned inside pizza, like name and price, those resources are also a part of olive pizza. So olive pizza also has its own name, has its own price and all that, right? So maybe you can have something like this. And now see the things that are just specific to olive pizza that can reside inside this. For example, if there is something called as allergy score, then that allergy score will exist only inside this class. Okay, and now you can pass that inside this constructor, and you will initialize that past allergy score to this allergy score which is present inside this particular class. So now it means that, hey, the parent class doesn't have to bother about the nuances of children. It's just like the parent says that, okay, these are the properties that I have, and these properties will be accessible to all my children. But my children can have certain private properties also, which is not to be shared with others. So those private properties deserve to exist as variables inside those classes only, not the parent class. So this is definitely something which is little better than what we were doing before. Before we were polluting this single class. Now we are at least not polluting it. Now, instead of one class, we have multiple classes, and the specifics of a particular class are present within that class only. Is it making some sense? How many of you are getting this? How many of you are getting this, that how and why this is little better than what we were doing before? I'm not saying that this is the final solution. Now, tell me what is wrong with this solution. Tell me one thing, how many of you have learned DSA before? So how do you work your way with a DSA problem? What do? You come up with a brute force solution, then you optimize it, then again you optimize it, again you optimize it. So you travel from, let's say, a solution which is n cube, you make it n square, and then you make it n, and then you make it log n. The same kind of thing we do here also. So we try to change an existing solution, come to a better one, and then we realize, hey, it has these problems, and then we make it a little better, little better, little better. And that is how we go on. That is how we kind of go on. So let me tell you what problems can arise. You know that, let us say, for now, we have two different kinds of toppings, not toppings, base. You know, every pizza, when you talk about any sort of pizza, it essentially has a base, and that base has different toppings on it, right? For example, you can have a pizza whose base is wheat, right? And then the first layer of topping is olive, and on top of olive you have cheese, and on top of cheese you have onion. So when you talk about a pizza, I can say that pizza is all about a base and then different toppings on top of it. Now, if let's say you have two different bases, the first is wheat and the second is millet, and you have, let's say, two different toppings. For now, you only have two different toppings. And let's say those two different toppings are onion and cheese. How many different varieties of pizza you can serve? Like, if you look at my question, one variety that you can serve is wheat onion pizza. Let's say somebody says, I want a wheat onion pizza. And then you can also have maybe a wheat, yeah, you can have a wheat cheese pizza. You can also have a wheat onion cheese pizza, right? So these are the different possibilities that you have. If your base is wheat, you can have wheat onion, you can have wheat cheese, and you can also have uh, wheat onion cheese, right? Similarly, when you talk about millet to be your base, you can have millet onion, or you can have millet cheese, or you can have millet onion cheese. Do you see that the number of pizzas that you can support, it grows exponentially? It grows exponentially as you increase the number of your bases or toppings. Just see the point. If you introduce one more topping, let's say you introduce tomato topping, what will happen? You will end up having wheat tomato, you will end up having wheat onion tomato, wheat cheese tomato. So this exponential growth is very harmful for this kind of design, because in this design you are saying that you will have one class for each variety of pizza. Like you have olive pizza. Now let's say you want to support wheat onion cheese pizza, then you would say that, hey, I want to write a class called as wheat onion cheese pizza. Now this is the problem of combinatorial explosion, where there can be different combinations and those combinations can lead to issues. So I can say that, hey, clearly this kind of code is very difficult to manage. It is unmanageable. Like even if I just have 10 or 20 different toppings, I'll end up creating millions of classes. Now imagine a code base in which there are millions of classes. So this is not an appropriate solution. Does it make sense why this is not an appropriate solution? So here, the kind of design choice that one can make is, one can say that, hey, let's imagine this thing in this manner. I can say that in order to create a new variety of pizza, let's say pizza new, what do? We take an old pizza and put a different topping on top of it, isn't it? This is what we do. Let's say there is an existing pizza called as wheat cheese, and now you introduce a new topping called as mushroom. So what you do is you take this wheat cheese pizza and you put a topping of mushroom, and now it becomes wheat cheese mushroom pizza, and then that is your new pizza, right? Are you getting my point? Now, going by this thing, I can say that, hey, every new pizza is a layer on top of existing pizza. It's literally a layer on top of existing pizza. So think of it in this manner. There is already an existing pizza, and this is wheat cheese pizza. Now I can decorate it with a layer of tomato. And now this thing, it is wheat cheese tomato pizza. So this thing, this complete thing, it has the property of tomato, it has the property of cheese, it has the property of wheat. And now tomorrow in the future, let's say I introduce a new topping called as garlic. Then I can put a new topping on it of garlic. And now I can say this is wheat, cheese, tomato, garlic pizza. So what we are doing is we are decorating the existing entities. There is already an entity called as wheat cheese pizza. It somehow exists. And now I am decorating a layer on top of it, another layer on top of it. This is a very well-known design pattern. This is called as decorator pattern. This is the concept behind decorator pattern. So how many of you are able to understand the concept behind decorator pattern? We will implement it later, but do you get what it is? Yeah. Okay. So how it is to be implemented, let us understand that. It's quite easy to implement it. I'll go back to my pizza class and I will clean a lot of dirt which is present over here. I'll just delete this existing class as it is no longer needed. And in my pizza class, I would say, let's do one simple thing. Let this pizza class contain name and price entity, because that is very basic thing that should be present inside every sort of pizza. And now I would say that, hey, whether you talk about a base or whether you talk about a topping, at the end of the day, that is like a pizza only for me, right? So I would say that let us write a class, a simple class called as each. Let us make it extend pizza. And now it has to pass the name and the price. So I'm not going to take it here in the constructor. I'm going to pass it straight away. Let's say the name of the wheat is wheat and the price of wheat is, let's say, 50, right? And then let me create another class. Let me call it millet. This millet is again something which extends pizza. And here the name is millet and the price, let's say, is 40. See, here you might feel it to be a little counterintuitive. You might be feeling that, hey, how is just wheat a pizza? Because when I say wheat, I just mean a wheat base. See, in reality, it can be a pizza, no? Let's say it's like a base condition. It's like a termination condition of your recursion. Just think of it in this manner. Base, the pizza base is just like your base condition, right? I can say that I want a pizza in which there is a wheat base and there is no topping. I'm health conscious. I don't need any topping. I just need a millet base. That's it. Just give me that. I'll eat it with whatever herbs I have. So what I'm going to say that everything for me at the end of the day is pizza. Even just the plain base is also a pizza. So wheat itself is a pizza. Millet itself is also a pizza. Now I'm going to write classes for the toppings. So let's say I talk about olive. I would say extends. See, now this is a very important thing. I had drawn a diagram to tell you that when you talk about this olive topping can be put on top of a pre-existing pizza. So let's say there is a pre-existing pizza. I can top it with a layer of olive. And the moment I top it with a layer of olive, its name changes. So let's say its current name is wheat pizza. Now it becomes wheat olive pizza and its price also changes. Initially, it all only accounted for the price of wheat. Now it will account for the price of olive also, right? So I have to wrap this olive on top of some pre-existing pizza. So what I'm going to do very interestingly is that, so I'm going to make it have a variable inside it of type pizza. And this is the variable on top of which the olive is decorated, right? So now I would say inside its constructor, it is going to take a pizza parameter. And the name for olive is going to be olive. The price for olive is, let's say, 20 units, right? And now I would say, so if you remember that diagram, I told you that the name of this pizza will be impacted by the name of olive, and the price will also be impacted by the price of olive. So what I'll do is I'll have to override these two functions. I'll have to override these functions, and I will end up saying that whatever is the name of internal pizza, that name should now have a suffix of olive. And whatever was the price, that price should have this much more price, whatever is the price of olive, which is 20 units more price. So I would say I'll just go to that function. I'll put them up over here. And it's just like function overriding. And now I would say that let's get the name of the parent, and to that name just put a suffix of olive. You can prefix it, you can suffix it, it's up to you, it's not a big thing. Right now, let's say if I'm prefixing olive something something pizza. So if it was cheese wheat pizza, now it will become olive cheese wheat pizza. And that pizza thing, I can suffix it over here. I can say that let's go to the bases. We had a wheat base. So we'll say this is just wheat pizza. This is just a base, right? Base doesn't have anything below it. It's like the termination condition. This is wheat pizza and this one is, I think I was making the change at the wrong place. I was making the change in millet. So I'll just trash this away from here and I'll put it here. We were supposed to make it here, right? Yeah. So in millet, I'll keep it as millet pizza. The base is named as millet pizza. Yeah. So here it is olive followed by whatever the name of pizza is. Similarly, here it is whatever the price is, 20 plus super dot get price. So you can see like what's happening over here. Like here, whatever layer you have put, we are accounting for the contribution of that layer, and then everything inside is the same. The same thing happens here. We are accounting for the new cost that has been added, and everything inside is the same. You can put a space after it. So what has literally happened is that your existing pizza has been decorated with a layer of olive on top of it. As simple as that, nothing else. Okay, so what this actually means is that if I go back to my main function, now I can say, let me just create a new wheat base. Okay, now what is the type of this? The type of this is a pizza, right? Because this thing extends pizza, so the type of this is pizza. So this object that I just created, this can be passed inside the constructor of olive, right? So I can pass it inside the constructor of olive. So what that actually means is I can say new of olive, and now this constructor contains this thing. And now what is this thing? It is nothing, but again, it is a pizza. Why it is a pizza? Because this olive class, it inherits from pizza, right? So this entire thing that I just created, this entire object that I created is an olive topping on wheat. Now, if you just see as an example, I can say this is my pizza P. And now if I do P dot get name, P dot get price, let us see what happens. So for me, it has printed, oh, it has printed olive followed by olive, and the price is 40. So there is something which is buggy, and we need to figure that out. So let's figure that out. So the moment I call p dot get name, what will happen? The get name method of olive will be called, and that will print olive, and then it will call super dot get name. So when it says super dot get name, what does it mean? That it is going to call the name inside, the name that is declared inside this particular pizza. But see, there is a mistake that we made while writing this code. What is that mistake? We do not want that name. We actually need to know the name of the internal pizza. If the internal pizza was a wheat pizza, we need to know the name of that. So instead of writing super.getName, we should be writing pizza.getName. And the same thing here, pizza.getPrice. Let's rerun this code. So yeah, now you can see it has printed olive wheat pizza and the price as 70. Why the price is 70? Because 20 units is the price of olive, you know. And then if you look at the millet, the price of, not millet, sorry, it was wheat, right? Yeah, the price of wheat is 50. So 20 plus 50 is 70. And that is what has got printed over here. So this is how it works. So what this decorator pattern kind of does is the topmost layer does it work, and then delegates everything to the next layer, and then the next layer, and then the next layer. See, now how simple it kind of becomes is that if somebody introduces new topping, let's say you introduce a cheese topping, right? Then all that you do is you write a cheese class which extends pizza. You create the constructor. And the same thing, cheese topping is topped on top of some pre-existing pizza. Right? And then you will have to again override those two methods, the two methods that you overrode over here inside Olive. I'm just going to copy them and paste them right here. So I would say that, hey, the name should be prefixed with cheese and the price should be added to the price of cheese, which was 50 units, right? Now think of it in this way. For now, I just have an olive wheat pizza. Now, let's say I want to create a different kind of pizza. I want this existing pizza to have a topping of cheese. If I want this to have a topping of cheese, then I don't have to create a new class for that. I don't have to create a new class called as cheese olive pizza or cheese wheat pizza or cheese olive wheat pizza. I don't have to do that. All that I'll do is I'll decorate it with a layer of cheese. And then when I run this piece of code, you can see that it naturally prints cheese, olive, wheat pizza, and the total price is 120. So the price of cheese, as we know, was 50. The price of olive was 50, and the price of wheat, was 50. So the overall amount is 120, which is printed over here, right? So what it means that if you introduce the new toppings, then that combinatorial explosion is now not going to happen. I had told you earlier that if you introduce tomato, then in the previous design where you are writing one class for each pizza type, you had to write tomato wheat pizza, tomato millet pizza, right? But in this design, you don't have to do that. You can just put it as a topping on pre-existing pizzas. See, that actually means that here, if I want to create a different kind of pizza, let's say I just want a millet and cheese. So I can do new of millet. Here I need not pass these things. And now if I run this piece of code, my main function, it should print cheese millet pizza, and it should print the price of it, whatever the price is. So you can see that it has printed it. The price is 90 because the price of cheese was 50, we remember, and for millet it is 40, so 50 plus 40 is 90. Now you can see the number of pizzas that are being supported is much more than the number of classes that we have. This is the most important thing to realize in this design. And how many of you have realized it already? Yeah, so this is just one example. See, low-level design is something which is vast. It contains so many design patterns, so many design principles. Not all of them can be talked about in one go, right? But yeah, definitely you can do one thing. I'm not sure how many of you have tried it, but we have a course called as Low-Level Design for Professionals. Why don't you take a free trial? You can take a free trial of that course of low-level design, and in that free trial you will get so many videos for free. Okay, and especially the videos on solid principles and the video that talks about how to design a chess from scratch, those videos will give you a very true picture of what is actually expected, right? See, this was a toy example. This example was to just give you an idea of the fact that how you can write a code which is much more cleaner. And now you can see this is much more cleaner, isn't it? This is very, very clean code. One reason why it is very clean is because you can see that I was creating different varieties of pizza, and I was able to store them inside this variable only. Why? Because all of those pizzas are children of the main pizza class. And this is a great thing. This is a great thing. It means that if there is a function which takes pizza as an argument, then that function can take any variety of pizza, be it cheese millet pizza, be it onion wheat pizza, be it any combination of pizza. It can take as argument, and then it can work on top of that, right? Now, tell me one thing, how many of you have used Java or know a little bit of things like buffered reader or scanner and all these in Java? So have you ever seen that a lot of times you end up creating objects in this manner? You say new of buffered reader, and then this takes some another kind of reader, maybe file input stream reader, and then that takes some another. So there is a lot of chaining of object which is done. So have you ever encountered such sort of code in Java? This is very popular, by the way. So what is this essentially? This is nothing but decorator pattern. This actually is decorator pattern where you are decorating one reader with another reader, and then you are decorating that with another reader. So that is how you go about. For example, let us say you want to read from file. You want to read from a file. So one way is that every time you call read function, whenever you call read function, what happens is that your file reader, it goes to the next line of the file and it fetches that data into the main memory, and then you can work with it. When you use buffered reader, what you actually do is you make sure that that buffered reader is just like a wrapper on top of file reader. So just think of it in this manner. Let's say this is your file reader. This is only capable of doing one thing. And what is that one thing? Let's say there is a file. When you call the read method, it goes to the next line and it brings that next line from the hard disk to the main memory, which is from your file to the main memory, right? Now, if every time you call read, then that is going to take a lot of time, right? Because reading from the main memory is expensive. So you can wrap it with a layer of buffered reader. What buffered reader does is that when you call the read method of buffered reader, it instructs the file reader to read several lines at once. Maybe instead of reading just one line, read 1000 lines and store those 1000 lines in a buffer in your main memory, maybe in a list of string or in an array or something. So that next time if somebody calls reader.read, I can just serve the data from that buffer. So buffered reader is just introducing a layer of buffering on top of the file reader. So this is just a decoration. File reader contains the nuances of dealing with file handling APIs. Buffered reader doesn't contain that. Buffered reader only contains the logic to instruct the file reader to read 1000 lines at once instead of one line. And those 1000 lines are stored in a buffer. And now what happens is that next time when somebody calls reader.read, instead of reading again from the hard disk, we will read from the buffer until unless this buffer is empty. Are you getting this point? How many of you are understanding? You do not just decorate the data elements, you also decorate the functionality. See, the toy example that I served you here, this pizza example, here you might have gotten a feel that, hey, we are just decorating the price and the name, which are data elements. But no, you can also decorate functionality, that there is an existing functionality. I want to use that functionality as it is, but I want that to be decorated with something else, right? Now, let's say, if you wish, you can go ahead and write your own reader. Like this example that I gave you, somebody can say that, hey, let's say there is something called as S3 reader. So S3 is a well-known service on AWS. So let's say you want to read some files from S3. So there will be a network call, and that network call will bring in all the data from S3 to your computer, and then it will store that in some file. And now for reading from that file, I can use file reader. And to make the reading process efficient, I can use a layer of buffered reader. This entire object that has gotten created is nothing but a reader. It is actually a reader only. You can call r.read and then the job is done. But now it is a layered object. When you call r.read, you actually call the read method of buffered reader. What buffered reader does is, if the data is present in buffer, it returns right from there. If the data is not present in buffer, it asks the file reader to read the next 1000 lines in the file if the file is present. If the file is not present, then this file reader falls back on S3 reader, asking it that, hey, can you please make a network call to AWS, download that file and store it somewhere so that I can read and serve it. So there is no limit to the amount of layering that you can do, but see the convenience, how convenient it has become now.